chapter 9. This chapter is on clouds and virtualization. So a lot of people can get easily upset that work in the cloud or that industry because of people don't really know what's working. Oh, it's just in the cloud. It works. There's a lot of infrastructure that goes on in the background. So let's imagine that us as a class, we start a company. What product do we want to sell or service do we want to provide? Think of something. A boot shining service? Yes. All right, I like that, right? All right, so we start a boot shining service. She used a black marker. Oh well. We start a boot shining service. Awesome. We've got some secret wax or method, right, to get the perfect boot shine that lasts forever or something like that, right? So that's proprietary. That's intellectual propriety. That's what makes our business be able to get into that market. Good? So we start a company. Well, we probably want to sell our services and go online, right? So we can host a website off of one computer. Probably not going to be able to handle much traffic, right? And you can use this computer for something else. So you'd probably want to buy what to host this website? A server, right? We probably want to buy a server. So we can get a rack. We can put in a server that'll host that website. And we might have two for redundancy, maybe some ups in there, some backup, maybe some switches, some routers to handle all that traffic. So we may have a rack to do all that stuff. Now, for us, we got to research. We got to figure out what we got to buy. We got to buy it. We got to wait for it to come here. We've got to then install power to it. We've got to ground it. And then we've got to turn it on. We've got to do all the configurations on it as well. That takes time. That takes money. Thomas? Well, this is just hypothetical, right? So let's not worry about those logistics. Let's just imagine we did have the money, the funding, and okay, not an issue. Good? Okay. But we can see that this takes up some time, some resources, some man hours to get this done. And then when we do, then we've got a server rack, or we've got a rack over here that's going to be powered on. That's going to cost energy, right? We've got to pay for that electricity. And that produces heat. So overall, right, our air conditioning for the building is going to go up as well. And we have less of a footprint. There's a lot of us in here, right? There's 49 students in here. If we have a server rack over here, there's less room for whatever these things are, right? But imagine if our company grew and we got to put more equipment in here. Then that's less and less room for our workers. And more people to maintain all of it. We got to hire the ITs to do it. Now let's say we go on Shark Tank and we advertise our product and all of the sharks want in because we're the best. Simply the best. Tina Turner. That's probably too old of a song. So what do we need to do? Well, very quickly, our website's going to get a lot more traffic and we're going to do a lot more sales, right? So we've quickly got to get more equipment, but we've got to research, purchase, wait for it to ship, unpack it, install it, put in the power, the grounding, and then configure it all again, right? That's going to take a lot of time. So as your company grows, it becomes less affordable or realistic for you to host your services at your own location. Instead, right, of us doing all of that, we can pay a provider that already has this infrastructure set up, and we can use their services. Does that kind of make sense to everyone? So they keep these things in what are called data centers. So data centers are just big facilities that have lots of servers. All right, so these are the racks, right? And here is a data center, and they've got so many racks that they're in rows after rows after rows of things, right? So you can see there, right? There's a hallway, and on each side are rows. Everybody with me? Okay. Roberts. Yeah, technicians. Data center technician, ITs, yourself. It is freezing in there, which is great to be in IT, right? You want to be in IT, working in cool environments instead of chip and paint, being a yeoman. We're also working in air conditioning, sometimes. So, the data center, right? It holds all of this stuff. A cloud is just remotely accessing that data center, right? You can have a data center without a cloud, but you can't have a cloud without a data center. Does that make sense to everyone? Okay. Abdul Shakur. Does a cloud allow you to have multiple, is what allows you to have multiple people on one server? Definitely, right? Because they're all just accessing that server, right? Remotely, right? So cloud. Shurna.
Is it kind of just like a manager for the server? Or no?
Just think of it. Let's simplify it even more, right? It's remotely accessing data. Good? Yeah. That data center. Good to go? Burnett? Tucker? Coffee? You said you wanted to watch a video?
Have you ever had something happen to your computer or mobile device causing you to lose important information like documents, photos, or music? Perhaps you had a backup, but restoring the lost data and the applications on another computer can be both costly and time-consuming. Or have you ever needed access to information on a specific computer, but that computer was somewhere else? Maybe you have the data on a USB drive, but the computer you are using doesn't have the right application software to access it. Traditionally, we store data and software programs on the computer's hard disk drive. This is known as local storage. But the data and the applications needed to access that data may be lost or not available. What if all that information, the data and the applications, were available over the network, in the cloud? The cloud simply means the information is stored somewhere else, remotely, accessible over the network, and typically over the internet. It is like having a remote hard disk drive that you can access anytime, anywhere. Many applications can be accessed using a web browser. These are known as web apps. A web app is an application software that is stored on a remote server and delivered over the internet through a web browser, such as Chrome or Firefox. Common web apps include Google Docs, Google Photos, Office 365. The cloud also allows for remote file storage and file sharing. For example, Google Drive, Dropbox, and Microsoft OneDrive. It is still a good idea to keep backups of your information, either locally or on a different cloud service. What if that cloud service is no longer in operation? How do you get your information back? Or even can you? And you need to be cautious about trusting your information to a third party. Are they taking the necessary security precautions to protect your data? What if the cloud company loses your data or has a data breach and someone now has access to all your information? The trend in the last several years has seen individuals and companies moving to cloud services more and more. The cloud offers many advantages, including always-on availability, being able to access your data anytime, anywhere. Independence from a single point of failure, no longer dependent on that data or software only being available on a single device or computer. Improved collaboration, allowing people to share information and collaborate more easily. Easier software maintenance. The company operating the cloud services handles all the software upgrades and maintenance. The point is that these services exist outside of your environment. And because these services have traditionally been represented as a cloud icon in topology diagrams, we now see that these services are in the cloud.
You're trying to stop the video so bad.
All right, do we have any questions? Abdullah Shakur? So if you put your data somewhere else, not on your device, but on a remote network, not on your LAN, that's a cloud, right? Remotely accessing it somewhere else. Tucker?
So is there a backup, say for instance you are that business and you have all your information stored on the cloud, what if that data center catches on fire?
That's a great question. So what data centers will do is they, like a company, they won't just have one data center. They're going to have them in multiple locations, and your data is going to rotate and not all be in one place, and they're going to do backups, and they've got insurance and guarantees and things for you. Abdul Shakur?
I remember I had broke my phone, I was doing too much, and I couldn't act like my phone was fried. It was in seawater.
Mm-hmm.
So when I had got the new phone, I was still able to get the backup. Is that cloud?
Yeah, correct, because your data was put on a remote server, so then later you could access it and pull it to wherever your phone was at remotely.
All right, bro. I was just
Good? Excellent. All right, so we've talked about cloud computing, but we haven't talked about is virtualization. Have you all seen the documentary Inception?
Yes.
It's a good documentary. It's got what's his name? That actor's name? Yeah, Leonardo DiCaprio. It's not a documentary? Inception.
Oh, no, I'm thinking about Interstellar.
It's a dream inside of a dream. That one. So virtualization, spoiler alert, you all have already done virtualization with your virtual machines. Earlier today, you were doing things on a computer inside of a computer. You saw that Windows operating system that you were doing commands on, you were changing the IP address. That was virtualization. You weren't changing your computer, you were changing that computer inside of the computer. Does that make sense?
A good example would be for those who play on Microsoft, they have a gaming service where you can play the games without actually having the software locally at your desktop.
An emulator where it emulates that software. So virtualization, we can do that for lots of things. We did it for operating systems already. You can do that for servers as well. We've talked about dedicated servers, right, where this server just does that one thing. But if I want my server to have multiple things, be capable of doing multiple things, you're going to use server virtualization to have on there, a web server, a file server, an email server, etc. And that way it can do more than one thing. There's different companies that offer cloud services. Amazon provides web services or cloud services. Does anyone know what that's called? AWS. Microsoft does with Microsoft Azure. There are a lot of companies. The cloud is becoming a big thing. So virtualization is one of the ways that allows cloud computing to be possible and do so much, because with us wanting our own company and those resources, it wouldn't work if, you want to store 10 gigs of your photos and have your own hard drive. It wouldn't make sense, right? But virtualization allows these things to be segmented and for different companies, different users to use their system, their infrastructure. Good? All right, so traditionally, right, that's what we're talking about, where, we'll have a server to host our website, our web server. We'll have a server for our email, right, a physical, its own piece of equipment, an SQL server, file server, DHCP server, et cetera, et cetera. Now, this is inefficient because you've got a physical piece of equipment for each service that you're doing. It's going to cost more money. You're using a lot more resources, including electricity. You're generating more heat. It takes up a larger footprint as well. Plus, imagine you've got, if we scroll down a little bit, 8 servers on this screen. If one of them goes down, well, that entire service goes down. Instead, if you had 1 or 2 servers, or 2 servers, let's say you got 2 servers, and you do virtualization on each of those, if this one goes down, you've still got this server that had all those capabilities on it. Does that make sense to everyone? Awesome. And server sprawl, that's the term that they're using here to talk about how you don't have enough space to physically house all of these servers, right? If I can do virtualization, then I can put in less physical resources within this space. Questions? Abdul Shakur.
Virtualization allows you to access all these servers at once.
Correct. So if we scroll down now, that's the next thing we're going to see, which is server virtualization, where you've got one piece of hardware, right? So before, we had a file server, DHCP server, web server, 3 pieces of hardware. But instead, I could have one server, right? Imagine that they're the same size, right? And we'll divide that into, part of that physical piece of hardware will be our web server, our file server, and our email server. Good? All right. Cerna.
Is it just the fact of taking less space, or is it...
Server sprawl is the term used to say it uses less space. But yeah, it uses less space. It's going to use less electricity to power, less heat, so less cooling costs overall, and allows you to have redundancy. So over here, if I had a HTTP server, a file server, and an email server, if this goes down, it's down. But if I've got now 2 servers, HTTP, file, and email, if this one goes down, we're still operating here.
So would they work at a lesser capacity than the individual servers?
Well, remember how dedicated are always the best, right? But instead, right, you spend part of your day on this, part of your day on this, part of your day on this, but it'll probably be part of it's here, and they work in conjunction with each other. Services will just be limited or reduced if one goes down. And they'll do load balancing. Good to go?
Yes.
So how does virtualization work? That is a great question, Chavez. I'm glad you asked. Let's not throw things in class. So if we, Abdul Shakur?
What was the case if, like, when a video game service goes down?
If it was a dedicated like service, like one game, that
Are you talking about like if a,
Let's say, like, I was playing GTA in Fortnite, the server just, like you know your Wi-Fi is good, you know, like, your connection is good, and you try to log in, it just says, server's down, you can't get into it. What is that?
they're either doing maintenance or
So it's not the
it
same,
could be a whole data center down. I don't know too much about the gaming industry.
so it's not the same for, like, so you don't use virtualization in cloud for gaming?
They could, yeah.
Like on a PlayStation, or would it have to be on a computer?
No, it'd be like the company would pay the cloud provider and the game would be there. Yeah.
Well, it's like that because for Steam specifically, you have games where it syncs all your cloud data to one spot, and then if you say you had all your data originally started on one computer, you go to another computer site and your account transfers over to that computer.
Bingo, yeah. All right, ready? Scroll down a little bit for me. All right, so what is an advantage of doing virtualization for servers? Well, you better use of your resources. You reduce the number of actual physical servers you have, the number of then networking devices you need. Networks are switches and routers, and the amount of floor space that it takes up, right? Less server sprawl. Less energy consumed because we've got less hardware to be powered, less devices that are producing heat where we got to cool down the building more, so we use less energy. So then, of course, we're going to spend less money on cooling, on electricity, on hardware, on everything. And less space, because also I need less, let's say we wanted to start our shoe shining business. Well, if I need all these servers and I need my workers versus, I can just do virtualization here, there's more room so we can be more productive. Or we could buy or rent less of a space. Faster server provisioning. That means how fast can you bring a server online, right? To this example here, let's say we needed to add a DHCP server. Oh, we'll just virtualize one here. DHCP, good to go.
So provisioning is how fast you can just bring it up.
Bring it up. Provisioning means configure, turn on, get it operational, it's up. And that's another advantage of servers, is you maximize that uptime, right? Because we don't want that downtime where, like Abdul Shakur was talking about with the gaming. Forbes. Say again.
Does that all fall in the category of
Redundancy,
redundancy?
yeah. Exactly. Improved disaster recovery. So if we click on that,
Exactly. So if one goes down.
if one goes down, right? During a disaster, right? This whole site is wiped out. Pensacola's gone. Well, guess what? We've got training facilities in San Diego, Virginia Beach, right? All that stuff, right? So if one site, there's a hurricane and the power goes out, it's okay because you've got redundancy in other places, or you can bring it up with virtualization. And support for legacy systems. So this is where your gaming comes into play. Have you heard of emulators? So you can play different and older games that aren't compatible on newer systems. What it does is virtualizes that old software, and then you're playing it within that software. It's virtualization. Good? All right, let's scroll back up. Up, 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 up. Right there. So there's something, because something's got to happen to allow this virtualization to occur. What creates the virtualization and manages it is what's called hypervisor. And here we can see we've got the hardware, then you've got your hypervisor, then you've got all of the different servers on top of that. And we'll dive into that in the next section, but it's hypervisor. It creates and manages your virtualization. I'll give you a second to write, and then we will check our understanding. NECs for virtualization? No. Not that I'm aware of currently. Creates and manages. Do we need more time? Yeah? Okay. Serna? When we get to the next section, if I don't answer, if it doesn't answer it, bring that back up. All right, more time? Garner, good? All right. Using virtualization, the organization can easily copy VMs between hardware platforms. Improve disaster recovery? Okay, next. Using virtualization, the organization can run an old program that is no longer supported on the current server OS. Support for legacy software. Using virtualization, the organization does not have to wait 2 weeks for an email server to be delivered. Faster server provisioning. Using virtualization, the organization lowered their monthly power and cooling costs. Less energy consumed? Using virtualization, the organization reduced the amount of required floor space. Less physical space required? Using virtualization, the organization reduced the number of servers from 30 to 10 servers. Better use of resources. Using virtualization, the organization lowered their network operation costs. We good with this? All right. Any questions? All right. So that was talking about servers, virtualization on servers. Now we're going to talk about virtualization that we've done in this class, which is client-side or host-side virtualization for the typical consumer. With me so far? All right. So this is becoming increasingly common and easier for organizations to implement. Now, why would you use virtualization? Well, one of the reasons, we've already done it in this class, which is for educational purposes. Of course, so you can learn about the different operating system. You could mess up your operating system or your virtual machine, completely mess it up, but can you still use your computer? Yes. You can, right? Then you just delete that virtual machine and do another one, right? So you can break that and you're good to go. So that's great for educational, for training. You could use it to test things out for a test environment. It's in its own kind of world, right? So it's less risk if something happens within that virtual machine, a virus, any issues. So we know about the host computer. So before we did our virtual machines, right? Before we learned about it, before we did it, right? You just had a computer here. So how you typically think of a computer, that's the host computer, the physical computer. The operating system, that's the host operating system. Make sense? Yes. When you installed the virtual machine, they were the guest, right? Because that virtual machine, some of us have already deleted and re-downloaded that virtual machine, right? It's just a guest. It's there temporarily. It's not always on that computer. It has the capability of being removed, but that computer is still there. So host versus guest, we feel good?
Makes sense.
All right. The host and the guest. So for us, right, our host and guest were in the same family. They're both Windows, but they do not need to be, right? We could, and we're going to later on install a version of Linux called Ubuntu. So you'll have a Windows operating system as your host, and then you'll have a virtual machine that's Linux, that it's a Ubuntu. All right, let's move on. All right, what creates and manages the virtual machine? Hypervisor. There are two types of hypervisor. Scroll down a little bit. Type 1 is native. Type 2 is hosted. So we can see on the left, we have our type 1, which is native. This is also called bare metal. This is what servers are going to do. Type 1 native, aka bare metal. That's for servers. This is what the server is going to do. Now, the difference between these is where is the hypervisor? So for us, right, we've usually got the hardware and the operating system is built on top of it, right? But now we've got this hypervisor that creates and manages our virtualization. So with a server, you've got your hardware and the hypervisor is right on top of that hardware. And then you can do your virtual server, your virtual DHCP server, your virtual web server, et cetera, et cetera. The hypervisor is built right on top of the hardware. It's a bare metal. That's type 1, that's native. used for servers. The other one, what we're using, is type 2, aka hosted or client-side virtualization. You've got your hardware and you've got your operating system, like your computer is normally. And then we have an application called VMware, right? That's our hypervisor. That's going to create and manage our operating systems. And when you open that application, you've got a tab for your Windows virtual machine. And later on, you'll have another tab that you can go to for your Ubuntu virtual machine. So your type 2, your hosted or client side, it's hardware, operating system, and then the hypervisor. Does the difference make sense, Jackson?
So type 2 is the operating system is there because basically we're using like this. This would be our operating system.
Correct. Yeah. We need some time to write.
Yes.
Okay. Which one do servers use? Type 1, aka bare metal, aka native. We use client side, aka type 2, aka hosted. Which one is directly, where the hypervisor is directly on top of the hardware? Type 1, native, bare metal. Which one is hardware OS and then the hypervisor? Hosted, client side, type 2. Give you more time to write. Yeah. Yeah, like on AWS, their servers would have type 1. So it's the hardware that's a server versus like the typical user would use type 2. And in a data center, right, those servers, to do the server virtualization, they use type 1. Griner, we need more time to write? Anyone else need more time to write? Yeah? Okay. Newton, good? Anyone else? More time? All right, moving on. More time? Yep. I appreciate you, Roberts. All right, so here we can see it's just another diagram of what we already saw, right? Type 1 native for our servers. And here we can see type 2 native, and it's using the hypervisor, an application, a company called VirtualBox. Which one do we use in here? VMware is our type 2 hosted client-side. Easy day? Scrolling down some more. Well, can anybody have a virtual machine? Or any computer? It's got some requirements. The processor support, right? Some are specifically designed for virtualization, but you're going to want to have at least a multi-core processor because they're doing multiple things. Memory, you need enough RAM, enough memory for each virtual machine. Remember in earlier chapters we learned about the minimum hardware requirements for Windows 8, Windows 10, etc. Well, for each instance or each virtual machine you have, you're going to need that enough RAM, right? If I've got Windows 10 and a virtual 10 virtual machine, I've got have enough RAM to support both of those devices. Good? Storage. Well, operating systems take up space, right? 20 gigs, 40 gigs, whatever it is, right? So you need at least enough room in your hard drive for that operating system, plus whatever files you're going to create and do in that virtual machine. Network requirements. Ours don't require, because we're not connecting ours to the network, but you could connect yours and bridge yours to the network. Yours will not be. So just like in physical computers, virtual machines are susceptible to the same threats, but they are isolated from the host. They can share some things. So it doesn't completely protect you from vulnerability. So don't think that unless you know what you're doing. So Hyper-V. This is Hyper-V, hypervisor. Requirements for Windows 10. The host machine, right, the machine that's going to run Hyper-V needs to be at least Windows 10 Pro or Windows Server 2012 or 2016. Processor has to be at least 64-bit with SLAT, second level address translation, to allow you to have network capability. BIOS, it's got to have VM monitor mode extension. Memory, got to have at least 4 gigs of RAM. And hard disk space, at least 15 gigs per virtual machine. For Windows 11, the host has to be at least Windows 11 Home or Pro. The processor has to be at least 1 gigahertz or faster with 2 or more cores. That is 64-bit. BIOS, it's got to be UEFI, and it's got to have TPM, Trusted Platform Module. Remember, we've talked about that before. Our passwords, our certificates, our encryption, etc. So you can do secure boot. Memory for this is also at least 4 gigs. Hard drive space, storage, instead of 15 gigs for 10, for 11, it is 10. Graphics. The graphics has to be at least DirectX 12 compatible with WDDM 2.0 driver, which we'll learn about in later chapters. We need time to write this down? That's just how it is. Yeah, it's more efficient for a virtual machine. Make sure we're not swearing, too. 10 Pro. More time to write? Okay.
You said the virtual machines, they can be on the network, right? So if I had a virtual machine, like if I was running it here, could I be on the same network as these computers in the virtual machine?
We don't do that here, but you could, right? Like if you go to home and you got a virtual machine, you could get on the internet in your virtual machine.
From the virtual machine, I could pay these computers.
Yeah, hypothetically. Yeah, but that would be, we don't really teach that. I mean, you could do like remote desktop, Windows remote desktop, etc. You'd be able to do that too. Don't worry about it. Garner.
Would you need a whole nother Windows? Because like how we did ours, we had to go into our desktop, into our program files and everything to get it. Do we still need to have a separate Windows key for that?
Oh, a product key or like the file that we downloaded from?
File.
Yeah, you would have a different what's called ISO to download that operating system.
Can we find that on our own personal computer?
Correct, yeah. Robert's good? Thomas good? Everybody good? Mac, you good? All right, let's scroll down. Let's see what we know. This is the operating system of the host computer. Host OS. OS stands for Operating System. This manages VMs and provides access to host computer resources. Hypervisor, Hyper-V. This is the operating system that is running on the VM.
Guest OS.
Guest OS. This is the physical computer controlled by a user.
Host computer.
Host computer. This item is typically used when describing hypervisors used in server virtualization. Type 1. Type 1 is also known as native,
And bare metal.
also known as
Bare metal.
bare metal. This item is used when describing hypervisors used in client-side virtualization. Type 2, aka hosted, aka client-side. Abdul Shakur.
When you go into the virtual machine, are you masking yourself? Are you masking your computer when you go from your computer to a virtual machine? Or are you just hiding yourself?
The virtual machine is more masked, not your host machine.
So you might be testing or running those things that you can't run on your computer.
This is a computer that exists within a computer. VM, which stands for virtual machine. Questions? Comments? Concerns? Cerna, sorry.
So about that virtual server again, I was just wondering how it stores any. I guess it could store data on the host computer itself, but that would kind of stop it from going further, correct?
Potentially. We don't get too deep into that.
Okay. Cool.